This is dynamic force mode, also known as tapping mode. In this mode of operation, the AFM oscillates the probe close to the resonant frequency and scans the surface, keeping at a constant amplitude reduction. How it does this? Well, first, the AFM sweeps through different frequencies to find at which frequency the cantilever resonates. This is where a tiny energy input produces a large oscillation amplitude. Then the AFM comes closer to the surface, and as the tip sample interaction increases, the amplitude of the oscillation decreases. Once the target reduction is achieved, the AFM tracks the surface, keeping this constant reduction. During every tick of the AFM system, the photodetector sends the deflection signal down to the controller. Inside of the controller, a locking amplifiers calculate the amplitude of the signal that happens at the resonant frequency. This amplitude is then compared against the reference amplitude to see how much is the amplitude reduction. This error between the desired amplitude reduction and the actual reduction goes to the PID controller, who decides if the set piezo needs to extend or retract. And thus the surface tracking happens. And this is how dynamic force microscopy occurs.